You ready in 3, 2, 1? All right, 4D was the homework, right?
Yes.
I'm looking at page 79, which is problems 1 through 9. Do we have any questions on 1 through 9?
Like the last 2 pages.
Okay, thanks for following directions, but I am on page 79. Is there any questions on 1 through 9? Number 9, thank you. Number 9, here we go. All right. First thing we were talking about yesterday. What's my critical value on this one?
0.
Good. So my critical value is 0. That's what I will be a certain distance equidistant from that point. Okay, that doesn't really go on your graph. It's just that. So then we go to solve this, and I subtract 3, so I get a 5. So I get x is equal to 5. And then the proper way to represent this is this, and then you show that this is changed to this. Is that okay so far?
Yeah.
Okay, number line. So you get negative 5, positive 5. If you really want, you can show your critical value right there, if you would like. Questions there? You can. Hang on, I want to play this video game real quick. Like the best game ever. All right, what's next? I'm sorry. 3. Some of you are talking too much. That's a nice hint. Number 3, we have the function at x is equal to negative 2/3 absolute value of x. And then we want to evaluate when x equals 0, 3, and negative 2. Include the substitution step. I don't know what that means. All I would do is this. Plug 0 in. Negative 2/3 times 0 is 0. That gives me 0. Plug 3 in. Absolute value of 3 is 3. Negative 2/3 of 3 gives me negative 2. Still with me?
Yep.
Plug negative 2 in. Absolute value of negative 2 is 2. 2 times negative 2/3 is negative 4/3. Done. All right. Turn the page. An awful lot of you supposedly didn't complete some of this page. That would be page 80. Looking at numbers 10 through 17 questions. Yeah. Which one are you looking at? Just okay, so give me one. Pick one from that page.
14.
14 sounds good. All right. All right, so the instructions say solve each of the following absolute value functions. Include your number line sketches. Okay. It's not asking for the critical value yet, but we'll just keep solving it for this. That's the point that we will be equidistant from. Agreed? So if I solve this, I'm going to break this down to 1/3 x plus 2 equals 4. My other equation is going to be negative 1/3 x minus 2 equals 4. Agree? Because you basically distribute negative 1 over your absolute value stuff. So I'm going to work this out. This is going to give me 2, so x equals 6. There's one value there. This one I'm going to get multiply each side, so I get by negative, right? Is that negative 18? All right. So here's my number line. So I have negative 18 here. I have my critical value here. And I have 6 here. Okay, my critical value was negative 6, so you're 12 units away from each. I guess you could put a dot here and then a dot here, and you're fantastic. Okay, and it's an equality, so you only have 2 points. You're not worried about what's going on in between your critical or your points. Yeah. 11, sure. Number 11, negative absolute value plus 5 equals 1.5. Okay. First thing I would do is I would go ahead and move the 5 over by subtraction. So if I subtract 5 from 1/2, I wind up with negative 3.5. Multiply both sides by a negative. So I get 3.5. So now this exists. So my answers are my critical value, if I wanted to list that, is 0. So on my number line, it looks like this. 0, 3.5, dot, negative 3.5, dot, done. That's a 0.5 in there. Sorry about that. Anything else on that second page? On the third page, which is page 81, what questions have you come across there? And are some of you starting to realize, oh my God, I made this harder than ever, then it's not that hard? Who said no? I heard an idea, but no one's wrong. 19? What's hard about it?
I just don't understand how you
So
make these equations.
All right.
You make all these equations out of one equation. Doesn't make sense.
All right. So there's the first equation. That's the original problem. We good?
Yeah.
All right. So the critical value, do you understand what that means?
Yeah.
That means what's going to be
Distance
equal. But
between each.
so all you do is you take whatever is in the absolute value sign, set it equal to 0,
Why would you say equal to 0?
because that's telling you what it rotates. It's always going to be that.
But where does the 24 go?
We ignore it for right now. We just find the critical value. It's not an answer. It's not a solution. It's just saying this happens to be the point that we are equal distance between. All right. So that x equals 2 is just a critical value. It doesn't go on the number line really at this point. It's just a critical value. All right. Next thing I'm going to do is here's my first equation. Are you okay with that?
Yeah.
Just drop the signs, right? Too much talking back here.
And then negative.
So then my second equation, I'm going to make this. Okay, so notice the signs that were involved with the absolute value sign are both different. So what I basically did is I distributed a negative 1 over. Okay? Good?
Yes.
Nothing else. So now I just have to solve those two problems. So I'm going to subtract 12, divide by negative 6. Is that okay? Add 12, divide by 6. So here's my two answers. So if I put it on a number line, I can list my critical value of 2. And I know to the right of that I'm going to have 6. So I'm going to put a dot right there. And I have negative 2 here. So negative 2 is 4 away from 2. 6 is 4 away from 2. 2 is our critical value. That's all it is. Where am I not making a right?
Then how would you do 18?
I don't know. Were you okay with 19?
Let's do 21.
Well, we asked for 18. That's what.
Oh, actually 21.
You want 21? You reverse that? 21. All right. 21. What happened with 21? 7 plus 5. Absolute value of 2x minus 3. Close absolute value equals 22. Okay. I'm going to find the critical value first. 2x minus 3 equals 0. What did I use as part of that? Only what was inside the absolute value. I didn't worry about what was outside at all. So I'm going to solve that. So x equals 3. So x equals 3 over 2. That's 1.5, right? Yep. So that's my critical value. So what happens to my critical value? We will be the same distance above and below it. Before I start breaking these problems up, I would subtract 7 from both sides. Keep the absolute value sign still there. So if I subtract 7, I get to 15. I have 5 times that absolute value, but I'm not going to distribute that 5. I'm going to divide each side by the 5, so then I'm going to have 2x minus 3 is equal to 3, because 15 divided by 5 is 3. Are we okay so far? Yeah? Good job on order of operations.
Oh.
Addition's a lower power than distributive power of multiplication.
Yeah.
Any other questions before we proceed forward?
Go to 27.
I'm not done with this one yet, but thanks for paying attention.
What? I'm thinking of it.
Okay.
Say 27.
First equation,
That's not.
No, the 20s.
I was just kidding. But
second equation. Are we good breaking the equations up? So I waited to break it into two equations before I had to move all my stuff over that was around. Yeah.
Does the 5 to 15 when you're subtracting that, doesn't that need to be 10, not 9?
Oh yeah, I divided it right here. This was division. Is that all right? All right. Let's see. Add 3. Divide by 2. Subtract 3. Oops, that's just 2x. Sometimes people freak out going, oh, x equals 0. Yeah, it's a number. No, but x equals 0. It's a number. It's okay. X is allowed to equal 0. Okay. Let's see. Did I do everything right? Let's see. Subtract 3, divide by 2. So my critical value, 3 over 2. 0 down here. Put a dot. 3 up here. Put a dot. So from 0 to 3 over 2 is 1.5. From 3 over 2 to 3 is 1.5 as well. Done. Anything else? Are we all set? Did the stapler make it to everybody? Or did anybody, Fiona, got one? Do which one? 2-4. You got it. Number 24. Okay, so I have 2/3. Absolute value of 5 minus x minus 4 equals 12. That one? Okay. All right. Let's find the critical value first. Is that okay? Again, that's what we will be, the same distance above and below. Let's start working this problem. So I get 2 over 3, 5 minus x. Add 4, so I get 16. Is that okay? Yeah. All right. I have 2/3 times the quantity, but I don't want to distribute that over the absolute value because that's kind of really bad math. So I'm going to multiply each side by 3 over 2. Multiply each side by 3 over 2. Is that okay? All right. So I can either go 16 times 3 to get 48, 48 divided by 2 to get 24, or I can go 2 goes to the 16, 8 times 3 is 24. It's your choice which way you do it, but same answer both ways. Is that okay? Fiona, good on that? Not done with the problem yet unless you have a question.
Shouldn't you do the multiplying by 3 halves before adding 4?
No,
I'm lost.
because and when you're undoing these problems, you reverse order of operations. You add or subtract first, then you multiply or divide. But when you're going forward, you're trying to solve a problem, but we're undoing a problem, so we're working backwards on it. Cool? All right. First equation's this. Second equation's this. So I'm going to subtract 5. That's 19. Divide by -1, -19. Sweet. And then add 5. Critical value is 5. So I get -19 down here. Positive 29 here. Each of those are 24 away from each other from our critical value. Anything else? We happy? Stapler made it all the way around. Make sure you're done. Okay. If you got a top mark and you legitimately did everything, go ahead and turn it in. If you got a middle mark and you didn't get it complete it and get it to me tomorrow for 3 points. You got a bottom mark, complete it, submit it to me tomorrow for 2 points. don't turn in something that's not complete if you have a middle or bottom mark or a dishonest top mark. I'm sorry. So some of you complained I gave some top marks, but if you notice as you come around with the homework, there were a lot of 2s on a paper for a score that were a top mark. So I do catch it. I just might not catch it right away. But thank you for recognizing my deficiencies. We good? Good? What? Oh man.
Make that 2. Make that 2 for it.
Hey,
Make that 3 for it.
3 for us? Yes. You always get water. These turn into Okay, you didn't find them? Oh man, somebody ran off with them. That's no fun. Okay. Anybody else? Anybody else? Oh, here comes a pack of some more. Thank you. Love it. Any more homework out there I need to remember, worry about, talk about, discuss, be happy with? So let's talk about, just have a quick think on a probability. This has nothing to do with math. Somebody asked, oh, you're not doing those little logic things anymore. Does anybody know how to find the probability of a royal flush? When you get only 5 cards.
5 8.
Okay, so what's a royal flush? Anyone know?
Same suit.
Same suit and
Straight.
straight, the highest rate you can get. So you want the same suit, which is whatever suit. You know, it's either clubs, spades, hearts, or diamonds. Okay? You want it to be a 10, jack, queen, king, ace. It's the hardest 5-card hand to get. Okay? If you have wild cards, there's other things, but we're not dealing with wild cards. All right, so let's see if we can figure this out. So we're getting 5 cards. 1, these are supposed to represent cards. Okay? All right, first thing we have to think about. We have 52 cards in a deck of cards. Still with me?
Yes.
How many of those cards are 10, jack, queen, king, ace? Total, yeah. How much?
1/4.
So hang on. 10, jack, queen, king, ace. There's 4 suits, right? So we have 20. So we have a 20 out of 52 probability of getting one of those cards. Now, if I deal you just 5 cards, if I shuffle it, I go 1, 2, 3, 4, 5. Doesn't matter which way you pick it up. If you pick up one at a time, pick them all up, put them in order. Doesn't matter. But there is a 20 out of 52 probability of you getting one of those cards that is 10 through ace. Does that make sense? This first card will determine what suit your second card needs to be. Does that make sense? Okay. So right now, we have clubs, we have the spade, we have the diamond, and we have the heart. Don't make fun of my hearts. Okay? So any of these could fit into this category. That's why there's a lot of cards. I mean, if you have a 20 out of 52 chance, it's a pretty good chance. You have a 32 out of 52 chance of not getting one of those cards. Okay, so you have a better chance of not, but it's not a horrible chance that you could get it. It's about a 2 in 5 chance, roughly. Okay? This is now said to be one of our suits. So the suit is labeled. Okay, it's one of the diamond, hearts, clubs, or spades. So now, how many cards are left? Let's figure out all these. Is everyone okay with how I got my denominators? Anyone stuck on that? I'm giving you extra cards. So those are pretty simple. So eventually these are all going to be multiplied together. Okay? All right. So now, of those 20 out of 52 cards that came to me, so let's just say for laughs, we got, of that 20 out of 52, we realized we drew the 10 of hearts. So we're trying to get all hearts now. Make sense?
Yeah.
How many more cards fall into the deck of cards that will be either a jack, a queen, a king, or an ace of hearts? How many cards are left?
51.
No, there's 51 total, but how many cards are left that will make our royal flush?
34.
4. How many cards are left now?
3.
How many cards are left now?
2.
How many cards are left now?
1.
Okay, so 20 times 4 is 80. 80 times 3 is 240. 240 times 2 is 480. Now, times 1 is 480 as well, thank you. All right, someone have a calculator, I hope? Yay? Someone have a calculator? You got one? Ready? Well, you go 52 divided by, or 52 times 51 times 50 times 49. And it's going to be a big number. Does it have an E in it? 52. Holy moly. 3, 1, 1, 8, 7, 5, 2, 0, 0. All right. So, a lot of you will realize so 1, 2, 3. You have that percent chance of drawing a royal flush off of 5 cards. So is it likely you get a royal flush dealt to you?
No.
No. You have a 99.985% chance of not drawing a royal flush. Guess which odds the casinos choose. You're betting that you will get it. Guess what they're betting on?
Wow.
So a lot of times on some of these games, a lot of times this kind of game will take place on a slot machine of some sort of video poker board. And it'll say put $1 in to win $1 million. And people are like, dude, $1 to win $1 million, someone's got to win. Yeah, but a whole lot of people are gonna lose, right? So these are things. Take a chance. $1 sometimes isn't really worth that much. You want to know the real demented thing about the state of Nevada? So ready for this data? Every casino in the state of Nevada covers 100% of their overhead costs. That includes lights, that includes water, that includes electricity, that includes everybody's pay. Still with me on this? Any other expenses that are taken care of are all covered on the nickel slot machines alone. Everything else is pure profit. No. So you get these people walking around, they got these cups of nickels. Oh man, I'm going to hit it big. Yeah. They cover all of their expenses on the nickel slots alone. Just make that one work. So what about the guy who's betting big? You can win big, you can lose big. Probability is you'll lose big faster than you win big faster.
Why would you marry you in that casino?
Yeah, what?
Because they always smoked in there. I got to my lungs. Oh, I didn't get you one. I'm so sorry. Copenhagen, yep. Gut vomit.
Where's the law?
Do you have a license to do that?
A license to chew? No.
No, casino.
Yeah, there's.
License.
All right.
Like to like own a casino.
Yeah, let's see.
'Cause you make that.
Yes. What do you got? What are you doing? Homework? Oh, thank you. You all right? Staying all quiet. I feel like I did something wrong. All right. Graph and write an interval notation. Ready? Ready? Ready?
Ready.
6. Open dot going this way to negative infinity. Interval notation. Negative infinity to 6. Done. The interval notation is the fun way of doing it. We don't necessarily always graph. All right, ready on the next one? I have a 5. Solid dot. Shading this way. Still with me? This goes to infinity. Still with me? This is now a square bracket from 5 to infinity. Why did I use a square bracket? Because it was equal as well. That's the interval notation. Is that okay? Seen this before?
Yeah.
Okay. I have a 0 here. I have an 8 here. This is where you get the question, how do you know the 8's on that side of the 0? I'll let you figure that one out. Okay, open dot at the 0. Close dot at the 8. Shade in between. Still with?
Yeah.
Okay. Interval notation from 0 to 8. Square bracket. Done. Cool? This one. -2 down here. 10 over here. I have an open dot here. I have a closed dot here. A shade in between. Interval notation, 2 to 10, square bracket. You seen this before?
Yes.
Cool. Obviously, you had a good teacher. There wasn't a whole lot of complaints. Wait, none of you had me for Algebra 1. God, man. Great. I got kids in my 8th period that had me. Man, they're going to tear this one up and be bad at it. Can I move on?
Yes.
All right. What caution must you be aware of when you solve inequalities? Okay? So sometimes an inequality won't allow you to have a solution to your problem. So, bless you. So, let's see. Which inequalities might be a concern? Well, let's see. This one, give me 34. That's what? 28. 27, excuse me. I can do math. Divide, bless you. So that sign flips. That seems okay. This one I'd probably subtract. Do this. Then I might flip the whole problem over where the sign's going to flip because I flipped it over. And then I flip it this way again. Why did this flip?
Negative.
What negatives? What about it?
When you divide by negative.
Because I divided or multiplied by negative. Okay? So are any of these cautionary yet? Well, letter A is not too bad. You have to remember that you have to flip the sign here. And I'm just underlining it in pink and flip the sign here. Those are concerns. B, sometimes you might have to flip it backwards. Let's see on this one. I'm going to add 9. I'm going to add 9 so I get to -3. Well, that isn't impossible. We could, again, put it on a number line and it should be fine. And then this last one, let's see. I have this. If I subtract 6, I get to 5. I multiply both sides by a negative, so that sign has to flip over. So I get a -25 over 3. So I'm underlining the pink ones, not because it's equal to. I'm just underlining those are where our sign had flipped over. If the number that is attached to your variable, the number that's attached to your letter, if that's negative, whether you're multiplying them to still hold together or dividing them to hold together, and so you're undoing it by multiplication on both sides or division on both sides, if it's division or multiplication by a negative number, that sign has to flip over.
You can really like flip the sign over like once you take one look at the problem.
Yeah, but just recognize if you are doing that, make sure you get rid of that negative then.
Okay.
Can I move on?
Wait, so which one was it?
A, B, and D are my only concerns because you would have to make sure you flip your sign over because you had to multiply or divide by a negative to get the variable by itself. Sweet. You're forever on YouTube.
Yes.
All right. So now we're going to get to the absolute value inequality. All right? I'll just go slow. You still with me? Still with me? Still with me? Anyone not with me? Dude, what are you looking at? You look everywhere over there. What's going on? No, don't blame other people. Don't blame other people. Choose to look up here and pay attention. All right. Choose to look up here and pay attention. All right, here's my first equation. Still with me? This one would have a critical value, just in case you're concerned, of 0. And then here's my other one. I'm going to do this. Do that. So if I divide both sides by 3 here, that's going to be this. If I divide both sides by -3 here, this is going to do this. Right? Did I do it right?
Yes.
Express answers in interval notation. Uh-oh, I have to think about what this looks like on a number line. Someone said. Okay, so I have -4 here, and a solid dot, and I'm going to go this way. And I have +4 here with a critical value of 0 of this, and we're going here. So this is known as an AND function. Okay, so my interval notation is going to be square bracket -4 to square bracket 4. Cool? Yay. Oh, I can't see all number 6. I'm sorry. Maybe I can scoot it up so you can still see both. All right. Ooh, our favorite. We got fractions. Shh. And then my other equation we'll do in red. Is that okay? All right. Add 6 to both sides. So if I add 6 to 1 1/3, I get to 7 1/3. So I'm just going to make that a mixed number, 21, 22 over 3. 22 over 3. Multiply both sides by 3. So that just becomes 22. There's my first answer. I didn't get my critical value. Critical value looks like, let's see, that's going to be 6, 18. Critical value is 18, I believe. All right, this one, subtract 6. Subtract 6 from that, I'm going to get 4 2/3. Forgot next. Okay, I'm going to make it a mixed number, or an improper fraction, so 12 14/3. Multiply both sides. Sign flips. Shh. So I get -14. So I get -14 down here. Critical value of 18 somewhere here. Oh wait, I goofed up someplace. Critical value 6. That should be right. And then 22. Cool. I goofed up someplace on here, but we'll finish the problem first. I got there. I got there. I got shade in between. So my interval notation, my critical value is dorked up, and I'm sorry.
How do you find critical value?
Take what's inside the absolute value, set it equals 0. All right.
Maybe positive 14.
It should be positive 14. I don't know why. Oh, it is positive. Why is it positive 14?
No, it just makes more sense.
I know. I goofed up someplace. I'm just trying to get to the interval notation, though. Okay? We got one last slide left. Can we make it?
No.
I think we can.
I don't think that happens. Not in a way that's like benefits anyone.
Huh?
Not in a way that like benefits us. Because then it's just speeding through the problem. It's not like.
We have 4 minutes to do 2 problems.
I really like
Now she's wasting your time though for you won't have to.
Sorry, you've wasted my time all year so far.
Better nothing but a waste of time.
All right.
Oh, dude, I'm so confused.
Why are you
Your sign.
Are we okay?
No.
I'm still going slow, right?
Yes.
Super slow? All right, adding 4 to both sides here, so I get to 15, so x is greater than 5. Yay?
Yep.
Giddy up. Subtracting 4 here. If I subtract 4, 11 minus 4 is 7. So x is greater than that.
-5.
What'd you get? So I get negative 7/3 here. I get 5 here. What's the problem here? I have an open dot going this way. And I have an open dot going this way.
It's just negative 7/3 to positive infinity.
No, it's
So-
5.
So, question.
Oh,
Hang on.
5.
Question. Shh. A number between negative 7/3 and 5 would be 0 is an easy number. Agree?
Yep.
If I take 0 and plug it in, I get 3 times 0 is 0. 0 minus 4 is negative 4. Absolute value of negative 4 is?
Yep.
4 is 4 greater than 11? No. So this is no in here. So my region goes like this to infinity. So I go from 5 to infinity. There's my interval notation. This part didn't work because it created untrue. It created a different thing. I think we could do number 6 or number 8 quickly, but I think you have the point of it. So your assignment, for those of you who are choosing to do it, is 4E, rock and roll. Get it? 4E. Yep.
I think I was in the bathroom.
Well, the one that's circled in yellow is your assignment for next time. Will someone bring me my phone?